In this video, let's discuss a past paper question. The question is, in the question, we are given a solid formed from a hemisphere and a cone. Volume and surface areas of a cone and a sphere is given, and we have to solve these three parts of the question. Consider the question again. We have to solve these three parts. Let's solve part A. For this, let's read the information given in the question. The solid is formed from a hemisphere of radius r centimeter, fixed to a cone of radius r centimeter and height h centimeter. And hence, this is the solid formed from a cone and a hemisphere given in the question. Now consider this solid. Volume of a cone and volume of a sphere is already given in the question, but we want volume of a hemisphere, and it is half multiplied by volume of a sphere, n is equal to 2 by 3 pi r cube. And we have volume of a cone and volume of a hemisphere. Next, it is given in the question that volume of the hemisphere is 1/3 of the volume of the solid. Volume of the hemisphere is given, and we get volume of the solid by adding the volume of the cone and the hemisphere. Let's write the given sentence in mathematical form. Volume of the hemisphere is equal to 1 by 3 volume of the solid, where volume of the hemisphere is equal to 2 by 3 pi r cube, and volume of the solid is equal to volume of the cone plus volume of the hemisphere is equal to 1 by 3 pi r square h plus 2 by 3 pi r cube. Let's put these values in the equation. We get, next solving and opening the brackets. Now we bring terms with same variables together. So we want this term on the other side. For this, we subtract this term from both sides so that they cancel out here, and we get this equation. Multiply both sides by 9 by pi r square, and we get 4r is equal to h, and hence part A is solved. We found h in terms of r. Now we solve part B, and part B is, the slant height of the cone can be written as r square root k centimeter, where k is an integer. Find the value of k. Here, the slant height of the cone is r square root k. Now consider this triangle. Here height is perpendicular to the radius, and hence they make a 90-degree angle with each other and is a right angle triangle. According to Pythagoras rule, in a right angle triangle, hypotenuse square is equal to base square plus perpendicular square. Now we put values and solve it. We take r squared to the other side of the equal sign. For this, we subtract it from both sides. and we are left with solving, putting value for h, we get, and hence we get k equal to 17. Next we solve part C. Part C is find an expression in terms of r and pi for the total surface area in centimeters square of the solid. Now the total surface area of the given solid is equal to the curved surface area of the cone. Plus surface area of the hemisphere. In this question, we are given that the curved surface area of the cone is equal to pi r L, where L is the slant height of the cone. And it is also given that the surface area of a sphere is 4 pi r square. But we have a hemisphere, and the surface area of a hemisphere is 2 pi r square. Now let's put values. L is equal to r square root k, which was given in part B. We know k is equal to 17 from part B. We got centimeters square. And hence we got the total surface area of the solid in terms of r and pi in centimeters square.